Good morning, everyone, or good afternoon, good evening, wherever you are. It is absolutely great to spend a bit of time with you. My name's Phil Nash, and I am a developer relations engineer at DataStax. And today we're going to be talking about building RAG applications with Firebase Genkit and Astra DB. I know a few people have said hi in the chat already. If you are watching, you want to say hi, please do join in. I absolutely love an interactive session, and this session is going to be absolutely getting hands on the keyboard to show you how to build using Genkit. So give us a wave, give us a shout in the chat. And also, please feel free to ask questions at any time. I absolutely love kind of interacting as we do this. So yeah, let's do that. As I said, my name is Phil Nash. You can find me all over the internet as Phil Nash on LinkedIn, Twitter, Blue Sky, Mastodon. I haven't put that link on there. But if you would like to connect with me, please do, so that we can kind of follow up and keep the conversation going after we have the stream. If you hit that QR code on screen, that just takes you to a bunch of links which link to other places that I am. So I'm joining you, as I said, it's this morning. I'm joining you from Melbourne, Australia. It is 8 a.m. It is winter has just started here, so it is cold outside. It is a little bit dark, but it is a nice time to be able to spend it talking with you about building RAG applications. And so I actually don't have much in the way of slides today. In fact, I'm absolutely going to jump straight out of these slides into writing a demo. Like I said, we're just going to spend the time building today. And so first up, I just want to kick off by telling you a little bit about Genkit. I don't know if you've, let me know in the chat if you've heard about Genkit at all before outside of the title of this talk. But Genkit is an open source framework. It's built by the Firebase team, so within Google, and it's built to make it kind of easy to build generative AI applications. Many people are building frameworks like this right now. Of course, we have at DataStax, we have Langflow, which is great for building drag and drop versions of this, but I think it's important to kind of branch out and see what else is going around right now, because there is many different ways of building generative AI apps. Genkit is primarily built for Node.js, but they are currently, as you can kind of see on screen, they are currently building a Go and a Python version, although those are kind of in beta and alpha stages right now. And so kind of a little, they're moving about. But because Node is unstable, at least they have kind of a target to aim for, which is good. And so Genkit is relatively straightforward to get going, and we are going to quite generally go from absolutely nothing. So I've got a terminal right here, which is ready to rock, and we are going to create ourselves a brand new application to build with this today. So I'm just going to create myself a directory of building. What should we call this? Okay, I'm just going to go with live stream. It is 8 a.m. I'm not feeling entirely awake necessarily. We can fire things up. That's what I've got coffee for. So that's what we're here for. I built myself a live stream thing, and I'm going to just npm init this entire application. Npm init. Yes. So there we go. We have ourselves a package.json file. Do give me a shout out, by the way, if this isn't big enough to see. I'll actually bump the text up a bit there just to help out. And actually, let's jump straight into VS Code. That's going to make life easier than trying to use the terminal the entire time. We'll just get VS Code going. And so I've got a terminal in here to use instead. Cool. So all I have now is a package.json file. And the first thing I probably should do is install Genkit itself. So I'm just going to npm install Genkit, and I will get the Genkit AI, Google AI plugin. So Genkit is mostly made of plugins, which is really kind of cool. There's this core Genkit, which gives you a load of stuff, and I'm going to show you a bunch of that as we go through. But then the rest of it, the actual services that you use, the models, the embedding models, the databases you use are all built as plugins. And so it's a very pluggable and extendable system. And the reason I'm talking about it today is because I did recently, I built the Astra DB plugin for Genkit. So we'll see that working in just a bit. I'm also going to, whilst I'm waiting here, I'm going to create myself a file called .env, and that is going to store my credentials in it. Now, I don't want you to see my credentials, so I'm going to promise you that I am going to store some in there, but I'm probably not going to show you much of them because I don't like rolling my keys. I like keeping them quiet, keeping them safe. But what you will need if you're using the Google AI plugin for Genkit, we'll be talking with the Gemini API for that. And so you'll need a Google Gemini API key. That comes, the easiest way to get one of those is to get into Google AI Studio and go hit get API key. See, I've got a bunch there, but we can create a new one. I'm not going to create a new one. I have one already, but I'm going to put it in there. But I'm going to put it in there secretly off screen so you can't see it. I bet by the end of this, I do accidentally show that, but we'll see. I've put it in there, and now you can't see. Cool. All right, we need ourselves something to actually run the application in, so we'll get ourselves an index.js file. And one other thing I just want to set up right now is just a couple of scripts inside my package.json file. I'm not going to type them out; they're just there. And these two scripts do two things. This start script is just going to start up the application or run the application just using the regular Node.js command. We're also passing it to that .env file so that it takes the variables in the env file and sticks them into the environment so we can use them, and then it runs the application. And then there's this Genkit command that uses Genkit start. And Genkit start sort of takes as a command another command to run. So like you're running the application and then you run Genkit to kind of run around it. And we'll see why that is soon. Cool, so we are fairly ready to go. We just need to start typing and start importing stuff and using stuff. And so I'm going to start with the absolute kind of basics. We are going to just set up Genkit to see how it works. And so how do we do that? We're going to start by importing Genkit from Genkit. That's a good start. And we will import that Google AI from the Google plugin. Cool. And so with Genkit, what you do to start with is just kind of create a Genkit application, which is a wrapper that's going to be used throughout the rest of this. So normally that is just under AI, and we're going to create Genkit and configure this Genkit application. And we do so, like I said, through plugins. And so if we create our Genkit application, we get plugins like that. That's almost all we need to do to get something out of this, which I actually think I think is really cool. So if I now run npm run Genkit, just in my terminal there, that is going to start up the Genkit server. It's going to start the application as well, but we get this Genkit developer UI, which is going to run on localhost port 4000. And so if I jump into that, this is the Genkit developer UI. I'm going to bump the size there. And so all we've done right now, is write 6 lines of code, 2 imports, and 3 setting things up. And we now have access to this entire interface. And as you can see, like our Genkit app is made up of 43 different models we can use, and 4 embedding providers. And I think that's kind of amazing. There are other parts to Genkit that we'll see in a bit, but we can go and look at the models and go and pick. I don't know, Gemini 1.5 Flash is actually getting deprecated, so I'm going to go for Gemini 2.0 Flash. And you can see, like, we now have this kind of AI dashboard to play around with. It's actually very similar to the Google AI Studio, but we're now running. Yeah, this is Google AI Studio that you can kind of access online, and it's kind of very similar to Genkit, which is familiar at least. I see Tom Ho was asked to have, are we recording this session? We are recording this session. We'll send it out later. Which is cool, hopefully. All right, so in here, we can set ourselves a system prompt. I'm not even going to do that right now. I'm just going to send it a message. What's something we can ask this morning? Write a poem about haiku. Yeah, about cats. Yeah, let's go for it. I'm making stuff up right now. Soft paws tread so light, a purring gentle rumble, sunbeam nap begins. Isn't that lovely? I was dealing with a different model earlier this week, which is actually built into or getting built into browsers. It's also Gemini based. It's Gemini Nano, and it has no idea what a haiku is. It thinks it's 3 lines, and then it just makes stuff up. It's got no restraint on syllables or anything. But Gemini 2.0 Flash is a lovely big model that we can trust to understand that. And you can see we can also play around with the model settings here, temperature, top P, top K, output tokens, where you want to stop it, loads of stuff. But that's it. So that's that's dealing with Genkit's interface based on just these 5-6 lines of code. We can get stuff in, we can get stuff out. I believe we can even. Oh no, it's not going to do it in here. There are ways to get, what's the word, media in and out of this as well. So we can add media. You could send in an image to ask Gemini to describe it, or there are ways to get images back out again. I spotted that just in the documentation here using Vertex AI and Ingestion. Anyway, we're not going to do image today. We're looking at RAG. And so what do we need for some RAG stuff? What do we need for RAG stuff? Yeah, we need ourselves a database. And so this is where we get to dive into Astra DB. And so I set myself up a database in Astra DB earlier today. They do take a couple of minutes to get themselves configured and live. But this is my new database that I set up just before this. If you want to get yourselves an Astra DB account, you absolutely can. I think Michelle shared in the chat earlier, there's a link to sign up for a free Astra account. It is free to sign up. It's free to start some databases and use some data. You can get quite a long way with the free account if you want to. Oh, and there's another link just in case you need it. Once you create yourself a database, we need a collection in which to actually store our data. And so inside here, we can go to the Data Explorer. I don't have any collections just yet, so I'm going to create myself a collection. And I'm just going to call this one Genkit. There we go. Astra DB collections can do a lot of stuff for you, which is really cool. For example, we have this embedding generation method. Astra DB methods, databases can generate vector embeddings for you. But for today, I'm actually going to use Genkit to do so, just to show you how it works. And we are going to be using, actually, if we go to Genkit, we have the embedders are right here. These are the available embedders, at least from Google AI's point of view. And I'm going to use Google AI text embedding 004. This is not the most up-to-date embedding, but it works well for me, and I know how to use it. So we're going to use embedding 004, and I know for a fact that that has 768 dimensions, much as other example ones do, like BGE base ENV 1.5. That's one of the open source ones. I can get that on Hugging Face. So 768 dimensions. We'll use cosine similarity to do the similarity there, and we're going to create that collection. Now, I might not have actually mentioned what exactly RAG is yet, and so I'm just going to go and dig into that whilst my collection gets itself set up. So RAG is this idea that our models, when we talk to them, don't have access to a lot of data, and so asking it to write a haiku about cats is fine, but asking who or which film won the 2025 Oscar for Best Picture, for example. If I ask it that, it has no idea. The Oscars, it says the 2025 Oscars haven't happened yet. And so RAG is this idea of taking a model and then augmenting it with a bunch of data that it can then answer questions based upon. We do that using a vector database because vector databases allow us to do similarity searches based on relevance, semantic relevance of answers to the queries that we put in. We get that using embedding models. Embedding models like capture the meaning of data. And so our Google AI, our Google text embedding 004 embedding model is going to capture the meaning of the data that we give into it. And our database is going to allow us to search for results via that meaning. And that's going to be really useful. And then once we've done that, we'll be able to ask our model things that it wouldn't have previously known. Great. So I've got a model that doesn't know things. I also love asking these things like, what is the date today? It doesn't know. And it will make it up. October 26, 2023. I don't know why Gemini thinks it's back in 2023, because I believe like the Gemini model's data cutoff date or knowledge cutoff date is kind of in November 2024. So it often tells me it's 2023 and it's just not. But they're all fun, these things. So we have some stuff to build in order to make this better. First up, what I need is to add some more secret stuff into my env file. So in order to access my database, I need this API endpoint, which is over here, and an application token, which I can generate here. And I'm going to put those into my env file as well. So actually, I'm just going to move that off screen so you can't see it, because I don't want to expose these things. I'm just going to copy this endpoint, and I'm going to copy this application token. I'm going to generate an application token, but it won't be shown to you. It's hidden. But I'm going to copy it, move that off screen, and just set up a couple of other little bits with it. And once I'm going to, oops, I'm just setting up, these keys so that we can't see them. Excellent. I'm doing it slightly wrong, but you can't see me doing it wrong, so we'll pretend it's all going fine. One other thing I do need to add is is the collection name as well, so I know what I'm dealing with there. What did I call this collection again? I just called it Genkit, didn't I? Yeah, there we go. Genkit, lovely. All right, I'm going to hide that before I put it back on screen. I have configured my env file, and I repeat the creation step, create the collection step. I can show you that, absolutely. Let's go have a look again. I'm not going to press create this time, but this is that create collection step. You give the collection a name, anything you like, as long as it doesn't have anything but lowercase or underscore characters. You want it to be a vector-enabled collection. That sets up vector indexes so that we can do our similarity search using so. And like I said, you can choose to either include an embedding provider like this NVIDIA one that's available. There are other ones you can set up within the Astra DB dashboard, such as OpenAI or Voyage or Upstage or Gina, I think, are all available. We're going to bring our own for this one because we are using the Google text embedding 004 model, which has a dimension, has 768 dimensions. So you set your dimensions that the embedding model is going to return. If, for example, you were using OpenAI, then you would use 1536 for the text embedding 3 small. If you were using text embedding 3 large, it'd be 3072. But we are on 768 for this one. And then once you do that, you just hit create collection and it will go off and create it. And so this collection is, that setup is what we've actually got here. Oh no, I've got 1536 dimensions. That's incorrect. What have I done there? I guess I will create a new collection. Yeah, thank you. I just noticed that. Well, how did I notice that? 768. Let's go. We'll call it Genkit 2. And I will create that collection and we won't use the old one because I got that wrong. Fantastic. Just going to change that in my environment variables to make sure I'm using the right one. Cool. So the collection is created. Thank you for pointing that out. That could have made me fall over a little bit later down the track. So now we have, now we have Genkit 2, which has 768 dimensions. Great. That's now correct. Thank you. Thank you for asking for the extra explanation, and thank you for pointing out that I got it wrong. Fantastic. All right. If I create a collection with the wrong dimensions, is there no way to correct it? No, you can't actually change the number of dimensions after the fact. So you would have to create a new collection. But that's fine, because you can't kind of, if you go trying to put a different number, a different sized vector into the collection, then the number of dimensions it's ready for, it will just reject it anyway. So if I'd done this, I would never have been able to store any data in the collection anyway, because I've been putting the wrong stuff in, and that would have been sad. But we noticed it early on. It does kind of fix the thing. I think it's because it sets up those indexes, and it's indexing based on the 768 or incorrectly on this 1536 dimensions. Cool. Where's my thing? All right, so if I'm going to deal with Astra DB, now I need to install the Astra DB Genkit plugin. And so this is open source. This is available on GitHub to go and check out, but it's also installable from npm install Genkit X Astra DB. And so you'll notice that most third-party Genkit plugins have this Genkit X prefix, and that's useful to point out or to find other Genkit plugins if you're looking on npm. There are third-party plugins for other databases, but also other models and things like that. So there are OpenAI. You can go get Genkit X OpenAI, for example, to go play with OpenAI models in here. Same for Anthropic, or you can use Llama from Google's Vertex AI. Same for Mistral. And if you even want to do it locally, you can use Ollama and the Genkit X Ollama plugin. But like I said, we're doing Astra DB, so I've installed that, and I'm then going to import 3 things from there. I'm going to import Astra DB, but also this Astra DB indexer ref. No, goodness. It does like to autocomplete for me. So we are getting stuff from Genkit X Astra DB. So we're getting the indexer ref, and we're getting an Astra DB retriever ref. There we go. And so Astra DB is going to be our plugin that we're going to use to set up the database. And then the indexer ref and retriever ref are just going to be references to an indexer, which we use to put stuff in the database, and a retriever, which we use to get stuff out of the database. Hopefully fairly straightforward. But inside our plugins array here, I'm just going to open that up and put in the Astra DB plugin. And inside here, we need to actually configure this a little bit. So the Google AI plugin, it did pick up the Gemini API key just from the environment. But I like to make things a little bit more here for the Astra DB one, in which we'll put in our client parameters. So these are the parameters we need to set up our database client. So that is going to bring stuff out of the database, out of the environment, the Astra DB application key and DB endpoint, and those are got to work out whether I called them that, key and endpoint. Yes, it is. Great. Trying to just, again, not show you my environment. So we've got the Astra DB API key and DB endpoint. And then we do need to set up a collection name, which is the Astra DB collection name. And finally, an embedder. And we wanted to use one of the Google ones for this. So I'm going to go and call it in from the Google AI plugin, text embedding 004. There we go. We're going to use that to do the embedding. That doesn't need any setup either. Cool. So that is the setup for Astra DB. And what I can just do is export comments rid of the indexer. So I'm actually going to pull the collection name out into a constant as well, because I'm going to use that a couple of times. The collection name is that. And that means I can just set it there. And we're going to get our indexer, which is our Astra DB indexer ref. And to that, we just pass the collection name. So we can use multiple collections in this. That's just going to key the collection based on that. And we're going to do the same with the retriever. And so this indexer is now capable of putting stuff into the database and embedding that content on the way in. And the retriever is going to be able to embed a query, use that to search the database and get results out. Now, I'm just going to restart npm run Genkit down here. Because if we go back to our, I'm not going to, something's gone wrong there. Good stuff. Runs for each. Oh, okay. You can actually set up multiple different parameters for this kind of stuff as well. So that is actually an array of things, not just a plain object. Cool. Now it's going to run successfully. There we go. Not successfully. Exciting. What's it done? Put an invalid URL because I am probably hitting the wrong environment variable. Trying to keep all this secret, and it's hard. I'm not quite sure what it's complaining about now. This is the fun of live, isn't it? It's saying invalid URL because it thinks I haven't given it a URL at all, I think. Which is probably because it doesn't think I'm getting it out of the like I said, it's before 9 a.m. here. I haven't finished my first coffee. I don't know what's going on. I'm just going to log out to see if that is indeed working. Yeah, that's there. Why would it be complaining at me? How weird. Bear with me 1 second as I just check my my notes on my other screen to see what's going on here. That's fine. So if I run Genkit, it should be fine, but it's not. Okay, exciting. We're going to fall to a backup in a minute, but I do want to know why this is not working, because I have a URL in there and it should be fine. I probably just typoed something somewhere, have I? Okay, bear with me 1 second. We do want to set our model. That's probably it. We're going to set a default model as well. And let's run that, and hopefully we're all good now. Yeah, now it's happy. I think it's because I was not setting a default model. So we're just going to set the default model there to Gemini 2.0 Flash. That should be fine. But now I've started that up again. We can go back to the Genkit interface, and we can see that now we have an indexer and a retriever for our collection. So we have an indexer here, which allows us to put stuff in the database, and our retriever, which allows us to go search for stuff from the database, giving it options like, well, we don't want to research, we don't ever want to return 0 results, but that's the default there. So our indexer allows us to put stuff in. And as you can see here, we can add kind of text data, we can add other kind of data around that, including metadata about the content as well. So we can save other things around the content too. But we don't want to just use these raw. What we want to do is use flows, and we don't have any flows yet. And so that is the next thing to define, is a nice flow for ourselves. And first up, I'm going to just create ourselves a flow called generate. And we're going to define these flows on the AI object using this define flow method. And flows need a couple of things. You need to name them. That's so that we can see them in the interface. And then they need an input schema and an output schema. And this actually gives us really kind of strong guarantees of what's going to come in and out of our flow, and now how to use around the rest of the application with kind of type safety. Now, I'm just building our example today in JavaScript, but this works really well in TypeScript. I just find TypeScript gets in the way if I'm doing things live. Apparently, I get in the way of myself when I'm doing things live as well, but like, we'll see. In order to use these input schemas, I'm just going to import this Z function from Genkit. And this refers to Zod, which is a JavaScript or a JavaScript TypeScript library that allows us to do runtime type checking in JavaScript, which is really useful for this kind of stuff. And so for our generate flow, I'm just going to say that the input schema is a string and the output schema is also a string. Very simple. That's all we want. We're going to put a string in, we're going to get a string out because we're just going to generate some content with it. And then so outside of this, we then have to register what that flow is going to look like. And so if we're going to get input from a prompt, we're going to output the result. And I just want to show building the basic flow before we then go and build our RAG flows. And so all I'm going to do is use const, I'm going to get text out of, AI.generate. And AI.generate is going to use our default model. It's going to send in a prompt. Oops. And then we can return that text. So really simple flow. This is really just calling to a model. I'm just going to restart the Genkit back in there. And it's refreshed. And now we have a generate flow. Cool. And this generate flow expects a string on the input and then is going to get a string on the output. So again, I'm going to ask it, what film won best picture at? And it still won't know, which is exciting to remember. Since the 2025 Oscars haven't happened yet, oops, I like this. The 2025 Oscars will be held in early 2026, sure. But if I ask about the 2024 ones, maybe that's Oppenheimer, right? So it doesn't know. It doesn't know what the 2025 winners were. The answer, if you're wondering, we're looking for is Anora. Oppenheimer was previous year. But yes, now we have this flow. But this flow is not very useful, again, because it's still just straight calling off to the model. So let's build a different flow. We want to build two flows for our RAG implementation. There's always an ingestion phase where we take a bunch of data, ingest it into the database, where we set up our vector embeddings for it, and then a retriever flow, the actual RAG flow, where we're going to use the retriever to search the database and get relevant stuff out, and then use that relevant context to generate a response. So let's go and build those. For the ingestion flow, I'm going to need some extra dependencies because I'm going to pull in some stuff from the internet. And those dependencies are npm install. We're going to call on Mozilla /readability. We're going to call in JS DOM. And we're also going to get the LangChain text splitters. And we'll see how we're going to use all of those in just a minute. But then once they're installed, I will just import them all. JS DOM. Yeah, we're going to get the text splitter. We're going to get the recursive character text splitter from LangChain, and we're going to get import readability from Mozilla Readability. Cool. So what we're going to do there is we're going to just get ourselves a new ingestion flow. We're going to define the flow. We're going to call it ingest. Our input schema is going to be also simple. It's going to just be a URL. It's going to be a string. But Zod allows us to do some more interesting kind of checking as well. We can say it's a URL. We can also describe it, which is useful for many things, but mostly other humans reading this kind of stuff. And our output schema is actually, we don't need an output for this. We're just ingesting stuff into the database. So I can say it's z.void. We're not going to get anything back out here. And then we're going to get ourselves an input, which is a function, which is the URL, and store that. So this is our flow. We've got our input schema is going to be a URL on the input. It's not going to return anything. And so what we're going to do is ignore Copilot. We're trying to complete things for me. We're going to get some text from a web page in this case. I always find that that's the easiest thing to do. We're going to grab some text from a web page. We're going to strip out the unnecessary stuff. That's what Mozilla readability is for. We're going to turn that into chunks so that we don't save too much context. We don't save entire web pages. And then we're going to store those chunks in the database. And so we're going to do that in a bunch of separate stages. Because one thing Genkit does really nicely is allow you to trace what happens during your flows. So what I can do is I'm going to get my text from the web page, and we're going to do so by using ai.run. And this allows us to kind of put a sync point into a trace point into our flow to understand what's happening. And we're going to name it. We're going to call this extract text, and it's going to run an asynchronous function with it inside of it. Cool. So with that, actually that's pretty accurate. Copilot is helping me out now. We're going to use fetch to get the URL. We're going to get the text out of the response. We have to create ourselves a kind of virtual DOM object, because Mozilla's readability is actually it's the readability mode of the browser Firefox. So if we look at, say, the Wikipedia page for the Oscars, we can go to readability mode, and this is what we see. It kind of strips away everything else, and this is really cool. Because we only want the text, we only want the kind of important parts. We don't want all of this and the rest of it. So let's go back here. So we then call on, we get the article out using readability. We have to parse the thing. And when we get that, we get like an object which has a title. We get the text content, which is actually, what we need. We get content, which is the HTML of the article text content, and a couple of other bits. I think the author is in there. That's not going to be much for Wikipedia, but basically this little subflow here is going to extract text from a URL now. Then we need to turn that text into chunks. So we'll do another trace point here. We'll do another ai.run where we'll call it chunk text. And here we're going to use one of my favorite chunkers, LangChain's text splitter. And so that's pretty normal stuff as well. So we're going to use this recursive character text splitter, a chunk size. I'm going to actually take that down to 500 and 100. And we're going to return now an array of text. And so that's what we get out of that. And then finally, we're going to take that and turn them into documents. So I'm just going to get one more thing from Genkit there. We're going to turn it into documents that we're going to use to enter into the database. So const documents, yeah. We're just going to map over these chunks and return a document from text. And so we're creating the document from the text. So that's the text becomes the content of this document, but we can also add in metadata. It doesn't need this metadata there. We actually just adding in metadata. And so in the database, we'll be storing both the text chunk as well as the URL it came from, which could be useful for filtering and things later. Once we've done that, we're going to store it in the database. Now this is potentially, it would seem like we'd have to think about a bunch of stuff, but here we're just going to await ai.index. we're telling Genkit to index thing, and we're going to give it the indexer, which is our Astra DB indexer. Indexer ref. We created an indexer for ourselves, didn't we? Oh, it's just called indexer. That's why. And the documents. So we're just going to say, hey, Genkit, index these documents using this indexer. And that's fairly straightforward. I'm going to get on and define the other side of this as well. Let's run it. npm run Genkit. This is going to restart everything, and we should have access to an extra flow now. So if I go back here, we had a generate flow. If I refresh it, we now have an ingest flow. Yes, cool. And so the ingest flow, this is great. Oh, sorry, a question from Kushagra there. Basically what we did was web scraping using a Mozilla LangChain and then created a document. Absolutely. We are doing web scraping. You can get your data however you like. Like this is not an important part of it, right? It could be, you could be loading a PDF. You could be getting stuff from an existing database, whatever it is. In this case, I just happen to be using readability in order to. We're scraping a web page. I'm using readability to get rid of the stuff that's not the main article text, and then I'm using the recursive character splitter from LangChain to split it into chunks. And so I'm going to do that to this Wikipedia article on the Oscars, giving it the information it needs to know. And so there is no output. Like I said, that was a void output there. But if we go into DataStax Astra DB now, we can refresh this. We should see a bunch of documents, which will have some important stuff about the Oscars. Boom, there we go. We've got 125 records. It's quite a big Wikipedia page. And here are all of our documents with the information about it. Sweet. That's very cool. We can have a look at the JSON just to see what's in there. Nice. Okay. So we've got stuff in our database. We did so just via the Genkit interface here by ingesting it here. We can also, I'm going to show you bits of this later. This is great. No, so what we did, we defined those steps, those run steps within the flow. We got this chunk text, we got this extract text steps. We can actually check the trace about what happened at every stage of this. So our ingestion flow took just over 5 seconds to run. The extract text section, this is what we got out of it. So no extra HTML around it, which is nice, but a bunch of information. We can see the results of chunking the text. So we've got this array of results with all the text kind of in chunks. There we go. There's just one chunk there that turned into the documents. And then this is adding it to the database. So we had 125 chunks there. They all needed to go and get embedded. So this is the first one. And we can see this is calling off to get the embeddings from Google's text embedding 004. This has all been done through the through Genkit. And so Kushagra's asking, can I do this similarity in Python to create a knowledge base essentially? Absolutely. Like I said, this is kind of showing how to do it using Genkit itself, but you don't need to use Genkit for any of this. You can write all the code yourself. Genkit does have an alpha Python kind of version, which would look the same and use this interface, but the code you'd write here would be slightly different just because it's Python, not JavaScript. I'm just going to crack on because I need to define my most important part, the most important flow, which is our RAG flow. So I'm just going to AI define flow. And thankfully, this one is, almost easier than the ingestion one, I think. We have to name it again. So I'm just going to name this RAG. I have to give it an input and output schema, and those are just going to be strings. And then I'm going to ignore whatever got generated under there. And then, so we'll get a query in. We're getting a query in from the user. And the first thing we're going to do is go use our retriever to retrieve results from the database. So we're going to docs, there's a wait, AI.retrieve. Again, we're going to use our retriever that was set up to the database. The query that we're sending in and we can just pass it some options. The options include, in this case, K, which is the number of results we want to actually retrieve. I'm just going to retrieve 3 results. We shouldn't need too many results in this case. We only have 125 documents to search from. But you might want to tune that based on whatever data that you're using in your own system. Once we've done that, we can then use generate. So we saw using generate earlier in this really simple generate flow, and we can do the same. So I'm actually going to just grab that from there. So that's just generating based on the prompt. But in this case, we want to write our own prompt. And I'm not going to do a bunch of typing for this. So I'm just going to copy that in. You're a helpful assistant. Use the provided context to answer the question. If you don't know, say, I don't know. I like that. It's fairly straight up. And you can pass the prompt. You can also pass those documents alongside it. And those are going to get injected into the prompt, into the context as well, allowing the model to read through that context and answer the question based on the information that we retrieved from the database. And that is all our RAG flow needs to be. So I can return the text from that. I'm going to restart our application in the background, and that should allow us to, Genkit has refreshed. If I go back to the home page, we now have 3 flows. So we've got a RAG flow. And again, the input for this is a string, but the output is also going to be a string. We can also choose to stream the output, which I like. And I'm going to ask it that question I've been asking it all the time, the one it absolutely doesn't know, not what the date is. I've not given it any more information about what the date is, but I have given it information about the Oscars now. And so I can say which film won the 2025 Oscar for Best Picture, and run that. And this time it's searching the database, it's got those relevant results, and now it says, according to the provided context, Nora won the 2025 Oscar for Best Picture. And so we can go check the trace on this as well. This is what we asked, the entire thing. That was our answer. That was correct. Nora did win. But we can see that we went and this is the input we gave to our database to make the retrieval. We asked for 3 results for this question. And our results included stuff about the nominees. So that didn't have the answer. You can see the metadata has come out here, so the URL is here. If we were using data from more URLs or different places, that would be useful to useful context. It looks like here, finally, we got this result saying Anora cleans up. Not a great set of results, honestly, but you know, Wikipedia articles are not maybe the best thing for this. Anora sweeps awards with Best Picture. Yeah, so like it answered the question in our 3rd document there. And so you can see that was the results there. We did embed the question, so we had to create a vector embedding for the question in order to retrieve these results. And then we did the generation side, where yeah, we passed in our prompt saying, where's the prompt? You're a helpful assistant. Use the provided context. That's that bit. But we also passed in all the documentation, all the context that it used to answer the question. And our response was had a lot more than just text in it. We could tell, you know, what all the usage and all that kind of stuff. So I do think these traces are one of the key parts of Genkit that make it really kind of useful to dig in under the hood of what's happened when you're making these requests. So we have got questions as well. Can we also see the similarity score whilst checking the trace? That's a good question. Maybe not, but hold on. I wonder if there's something I can do about that, because probably not. No, we can't. The similarity score would be returned by the database. You know, I haven't thought about that before. We can actually return the similarity score from the database, but I don't think it's set up to do that right now. And that might be useful. You know, that is actually something I can add to the Astra DB plugin. I'm going to write myself a note for that, because that's really useful. Return similarity score. I don't know if Genkit would make that available, but it would be really useful context, especially when you're looking into this. So great question. Thank you, Cassandra. That's not something we can do right now. But what we have done right now is what have we written here? Just over 100 lines of code. We've written ourselves an application that can plainly generate content. That's not our most useful flow. We've written one that can ingest content into a vector database, into Astra DB, using a URL and stripping out other stuff, turning it into chunks and placing it into the database. And we've written a RAG flow that uses an incoming query from a user to search the database and return that relevant context and generate an answer based on it. We've done that in about 100 lines of code, and we've created ourselves this kind of framework of flows, embedders, indexes, and retrievers that can be used throughout Genkit to run these. And so, whilst we've seen these in the interface here, you can actually just then take the flow. So we can take our RAG flow, for example, and just call on it. We can run the flow using an input. So who won Best Actor at the 2025 Oscars? Come on. Those are the results I have. Const response equals await. Oops, RAG run. And if I just console that response. So this means that you can use these flows within your application as well. They're not just trapped inside the Genkit interface. And if I go and just restart that, what it should do is actually run this flow at the bottom as well and return ourselves a full response. It's not going to do, there it is. Haha, cool. Oh, okay. It didn't get the answer. But point being, you can run these flows now inside your application as well. But I really like Genkit because this allows us to experiment and play around with these flows. We don't have time to dig into it today, but aside from the traces that we could see, which included, this is the one I just called out from inside the code, and it didn't find the right stuff. So that's it's a real shame. So we can go and look into why it's not found stuff. We can also build evaluations, allowing us to test our flows using Genkit's kind of ability to evaluate stuff and set up data sets with which to do that. And so that's kind of what I wanted to show you today. We've gone from absolutely nothing to a full set of Genkit flows that allow us to do RAG using Astra DB that we can now use inside an application however we want to, whilst also keeping an eye on the traces for all the calls and later, if we wanted to, build evaluations and data sets to build upon that. So that's Astra DB and Genkit. Here are some links that might be useful for you. That's a link to the Genkit docs, just at genkit.dev. There is the Astra DB plugin for Genkit under the DataStax GitHub under Genkit X Astra DB. And if you want to kind of go through this yourself, this blog post here, building a RAG chat app with Genkit and Astra DB, will walk you through all of this again in a bit greater detail and at your own pace. So that hopefully Michelle can share those just in the chat as well for you. But those are the links. Again, my name is Sonash. I'm a developer relations engineer here at DataStax. It's been an absolute pleasure to chat with you this morning. Again, please do connect with me online on LinkedIn or something, and I'd be happy to take any questions. There are those links. Thank you, Michelle. And yes, this session should have been recorded. So if you're now watching the recording of the session and I'm telling you it's been recorded, you already know that because you're watching the recording. But if you've been with me live today, thank you so much for joining me. We do have a couple of minutes if there are any questions. Other than that, I would say, please go and experiment with all the different ways you can build these applications. There are a whole different frameworks and ways of building your RAG applications. Of course, Langflow is another one that I think you should obviously check out because that is our open source version of this, allowing you to build generative AI flows using drag and drop. So go check out Langflow as well. But if you like the idea of writing code and Node.js, or in the future Go and Python as those versions are created, then do go check out Genkit and check out the Astra DB plugin for Genkit when building your RAG applications. I am not. That's really nice to hear from Heather. Kishako, you're building your own chatbots. This is what you do. That's awesome. That's awesome. So yeah, thank you so much for joining us. I don't see any other questions, so I'm going to end the stream right here. But it's been absolutely brilliant hanging out with you this morning or in your afternoon or evening. And we will see you next time. Thanks so much.